Okay, here we are, part 3 of the electron config practice. All right, so they're just asking me what element this is. So I know that krypton is 36 electrons, right? So 36 plus 2, 38, plus 10 is 48, 49, 50, 51. What has 51 electrons? Antimony, Sb. Xenon has 54 electrons. 54 plus 2 is 56. Plus 14 is 70. 76. 76 is osmium. Radon. So that's got 86. Plus 2 is 88. Plus 11 is 99. What has 99 electrons? It is Einsteinium. Einsteinium. All right, determine which of the following electron configurations are not valid. I don't care about the state your rule because we haven't learned Hun rule. So let's just look at this and compare it to what we know about the off-bow chart. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4d10. 4s2 to 4d10. I don't think that's true. So let's look. 4s2 to 3d10. Aha! So this is a big old lie right here. And that is not valid. 1s2, 2s2, 2p6, 3s2, 3d5. So does it go from 3s3? No. S's don't hold 3, they hold 2. And even if it did hold 3, they also violated 3p. We didn't go to 3d. So I see 2 mistakes on here. So that is not valid. Okay, next one. Radon. Looks like we've got a noble gas abbreviation here, except that radium is not a noble gas. If it's not a noble gas, you can't abbreviate with it. Not valid. Oops, sorry. Not valid because of that. Ra, right there. No, not possible. All right. Krypton. And then we go from krypton to 5s2, that's true, and then to 4d10. So we go from 3p6 to, wait a minute, no, where do we go? Where are we at? Where are we at? Krypton, krypton, krypton. This is 4p6, so we start at 4p6, we go to 5s2, that's true, and then we go to 4d10, that's true, and then to 5p. Oh, this is a good one. Valid. Valid. And until further notice, we're going to say that this is valid too. I think it. Honestly, I think you should go back to Krypton and do KR and do all the parts in between that go to Xenon. So it should be KR 5s2 4d10 5p6 is what it should be. But I'm okay with this, like leaving it like this for right now. Okay, then we got into orbital diagrams. Orbital diagrams are easy as long as you remember the rules. Now remember, electrons have the same charge, so they want to stay away from each other like magnets. So within a given orbital, they're going to stay as far away from each other as they can. So I've got nitrogen. Nitrogen has 7 electrons. So here's how we fill. We have to fill each orbital completely until we get to the last orbital, and that's the only one that won't be full. But the way we fill is we do 1 up and 1 down, and 1 up and 1 down. And then I need 3 more. So if I do like this, up, 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 these guys can stay as far away from each other as they can in that 2p orbital. I cannot do this because you're trying to scrunch them all together. And these electrons don't want to be that close to each other. It's like a parking lot. When you see a parking lot with parking spots and you see that there's a car here, you're not trying to park right next to them, or at least I'm not. I like to park with a little bit of gap in between. It's the same thing with these electrons. So 2, 4, 5, 6, 7, that's done with that 7 electrons. I didn't really care if you did the full electron config for these guys, because by now I'm hoping that you know how to do an electron config, although some of you might be proving me slightly wrong. All right. Chlorine has 17 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That was easy. I mean, that didn't even require any knowledge. Like if I had put all these out here, it would have been fine, right? So sodium. Sodium has 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Done. Remember, just fill up every spot with 1 before you put a second one in. That's all I'm saying. That's the only rule here. Fill up every spot before you put a second one in, or put 1 electron in every spot before you put a second electron in. So neon. Neon has 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It makes sense that it has 2p6, that it's full, because it's a noble gas. This is happy. This is a... So what this means is, in the second shell, I have 8 electrons. And what is every single atom after? 8 electrons in its outer shell. Neon is happy, unreactive even. All right, nickel. We have 28 electrons. 1, 2. Oops. 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. Oh, I broke my own law, didn't I? Did you see that? Did you see that? Okay, so remember, we have to put 1 in each before we put 1 going down. So 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Done. Remember, 1 electron in each space until we fill up all the spaces for that orbital. Then we can add the second one going down. All right, vanadium. How many electrons? It has 23. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's it. That's vanadium. I don't put, remember, 1 in each until you get all of the spots in that orbital with 1, and then we can backfill. All right, copper, last one, 29 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Done. All right, guys, that's about it for the old electron config sheet. I hope that helped at all. If it did, let me know when you come into class. Let me know that you watched the video. The reason I keep making these is so that you guys will watch them. If you stop watching them, I'm going to stop making them. All right, guys. Catch yous.